Hello everyone and welcome to another Physics 210 lab simulation walkthrough. As always, my name is Alec, and probably like I'll say at the beginning of each of these videos, please make sure that you've read through the theory section and the attached lab manual and that you understand that to the best of your ability. When you're ready, go ahead and head to this website to pull up the simulation here and click on the Buoyancy playground section, not the intro section. Perfect. Okay, so should be a pretty quick one today, so that's some good news there. Let's get into it. So first we're going to be using some objects that are heavier than water. First thing to do is to click the material bubble in the top left. So we're not creating our own blocks, though if you would like to play around, feel free. But the data for this lab is going to be solely based off of these materials here. And once you've done that, go ahead and uncheck everything else in the bottom left here except for the masses section so that you can read off the masses of things. And then first off, what you're going to do is make sure that you have a table or an Excel spreadsheet ready to collect some data. We're going to be recording masses of these objects, two different weights for the first part. So we're going to record an object's weight in air and its weight in water. And then we're going to be calculating its specific gravity within the water, which all those equations and whatnot are given in the attached lab manual. So, like I said, it should be a rather quick one, so let's jump in. Okay. So the first thing to do is click the brick button, so we've done that here, and to weigh it in air and record that weight. So its weight in air is 196 newtons. Of course, its mass here is set to be 20 kilograms, so 20 times 9.8 will give you 196 newtons. So go ahead and record that. Next thing we're going to do is go ahead and note the volume of the water that is present while nothing but the scale is in there. So it's 100 liters of water. And next we're going to record the object's mass, which hopefully you've already done. Place the object in the water now and record its new weight, or its weight in water. So you'll note this scale reads less than 196 newtons. It actually reads 98 newtons. And the new volume of the water is 110 liters. So that should mean that about 10 liters of water was displaced because we started with 100 and now there's 110 liters in the entire thing. So about 10 liters of the water was displaced. Now, using that mass, well, I won't go through this calculation here, but I will encourage you to do so. Use the mass that we found in step 3 and the volume in step 5 to find the density of the cube, and then check that to make sure that it lines up with the simulation's value. And if you have any errors there, go ahead and explain those away. And next up is to, of course, do this calculation and use the weight of the object in air and the weight in the water to determine the object's specific gravity from equation 4 in the lab manual. And then we're just going to repeat these steps with aluminum. So, just to run through that real quick again, we've got a 20 kilogram brick, which in air weighs 196 newtons and in water weighs 98 newtons. That's really all the data you need to collect, and then also the displacement of water is 10 liters. Alright, so let's jump over to aluminum, where we've got 10 liters of aluminum at 27 kilograms. So in air that weighs 264.6 newtons, and in water that weighs 166.6 newtons. And again, we've displaced about 10 liters of water. So you can use that to calculate the density of this block of aluminum, and then calculate its specific gravity by way of its density, and also its weight in water and its weight in air. So again, aluminum, 27 kilograms, weighs 264.6 newtons in air, and 166.6 newtons in water. So that should be all the data you need for the first part. That was pretty simple, of course. So once you've done all that, just make sure that you go through all those calculations. And next up, we're going to be doing some things with objects that are lighter than water. This is a pretty trivial part of the lab as well, but here we go. So the setup is the same as the first part, and the procedure is just to bring up wood and take the object fully out of the water, so just make sure it's out of the water, and note that volume of water that's there. It's still 100 liters, that hasn't changed. And next up is to fully submerge the object and determine the amount of water that it displaced when we fully submerged it. So as we fully submerged it, we displaced 10 liters of water, which is good because the object itself is has a volume of 10 liters, as determined by the simulation here. So once we have that, you can go ahead and calculate the object's density by dividing its mass by the amount of water that it displaced, and then check to make sure that that lined up with the density of the object on the simulation that we've given you. So 4 kilograms divided by ostensibly 10 liters of water, and I'll leave you to determine whether that lines up with the values of the simulation. And next we are told to switch it over to styrofoam, ice and styrofoam, So we have a 1.5 kilogram block of styrofoam, drag it in the water. We've displaced 10 liters with it, or we've displaced 10 liters with it because we started at 100, go to 110. You can use that to calculate its, along with its mass, to calculate its density. And finally, we go over to ice. Go ahead and drop it in there, and drag it underwater. We've displaced about 110 liters, and of course, it weighs 9.91 kilograms, or 9.19 kilograms. So go ahead and make that calculation there. And really, that's that is it for this lab. So go ahead and do the data analysis and answer those questions, and make your charts, do your calculations and all that. But that is really all of the data you need for this lab. Of course, if you need to go back and watch through this video once or twice or whatever, I know I probably went a little quick. Feel free, and email me with any questions you have, or join my question session on weekdays from 1 to 2 p.m. Otherwise, I will see you later. Have a good day.